In AM detection, we have to see the type of receiver and how we are receiving the signal which has been transmitted. In the AM receiver, we are having basically two types: TRF, that is tuned radio frequency, and super heterodyne receiver. The drawbacks of tuned radio frequency we overcome in the super heterodyne receiver. Practically, we are using super heterodyne receivers. So in the lab, we are implementing the super heterodyne receiver, which is envelope detector for AM detection. For DSP FC, we are using envelope detector. In the AM receiver, we are having first model is the tuning of the transmitted signal. When we are doing the tuning, we are using class C tuned amplifier, so that at the resonance frequency will get the high output. In the super heterodyne receiver, we are having first block as pre-selected, where we can vary the frequency of the received signal in such a way that the output of the mixer will be intermediate frequency. We are receiving the RF signal, so initially we are amplifying that RF signal and we are giving that signal to the mixer, where we are generating the intermediate frequency. Intermediate frequency is a fixed frequency which is quite lower as compared to RF frequency range. So the problem which we are having with the receiver, that is the instability of the tune frequency, we can overcome with the help of super heterodyne receiver. The intermediate frequency in AM is 455 kilohertz. Then we are using the 2-3 stages of IF amplifier, and then we are giving that signal to the diode detector, and the output of diode detector is nothing but the demodulated signal. In AM detection, we are having two ways to decode the signal. One is the synchronous reception and another is asynchronous reception. If we are dealing with the DSB FC, then we have to deal with the asynchronous receiver. Before we deal with the receiver, I will explain what is synchronization. If we match the phase and frequency of carrier signal at transmitter as well as receiver, then we can say we are having a synchronization between transmitter and receiver. In case of DSB SC, in case of DSB FC, we can use the asynchronous reception. The last element in the AM transmitter is the transmitting antenna, and in case of receiver, we are having first element as a receiving antenna. We can do the wired as well as wireless connection. If we are having two antennas, or if we are doing the wireless transmission, then we have to see the antenna knob should be enabled. For the wired communication, we have to connect ground for both transmitter as well as the receiver. Then we have to connect the transmitter output with the receiver input through the wire, and make sure you are making the socket option enabled. In the wireless mode, we are doing the transmission through the antenna, so we are making sure antenna should be enabled. The first thing which we have to do in the receiver is we have to tune the signal. The many antennas, they are transmitting the signal, and at the receiving antenna we are having multiple signals, out of which we have to select the desired signal. So we will do first the tuning of signal. When we tune the signal, we'll get the high amplitude signal. Once we tune the signal, then you have to shift the knob to the output select. On CRO, to the X channel, we are showing the modulating signal, and to the Y channel, we are showing the demodulated signal. As we see the result, the modulating and modulated, both signals are having same nature. If we increase the amplitude of modulating signal, we observe the amplitude of modulated signal is also increasing. In the observation table, we have to measure the amplitude of the output voltage. So we can measure it with the help of multimeter. As we increase the amplitude of modulating signal, we'll observe in the multimeter, we are getting the increased output voltage. In AM receiver, we have to study the concept of AGC, which is automatic gain control. This AGC signal is a DC signal which is driven by the diode detector. Here we can see we are giving the output of diode detector to the AGC circuit. If we are making AGC in, then with respect to the input voltage, we'll see the AGC is decreasing. The functionality of AGC is it has to control the gain of both RF as well as IF amplifier. As we increase the amplitude of the modulating signal, then we can observe on the CRO the amplitude of the received signal is also increasing. Likewise, the amplitude of the AGC signal is also varying. With increase in the amplitude of the modulating signal, the value of AGC has to decrease because it is decreasing the gain of both RF as well as IF amplifier. If we want to see the effect of AGC, that is automatic gain control, then we have to see if I am increasing the amplitude of the modulating signal and if AGC is in, then we will get the constant signal throughout the signal operation, though we increase or decrease the amplitude. As I increase the amplitude of the modulating signal, we will not see any change in the audio signal, in the noise which we are listening. But if we make AGC out, then we'll see with increase in the amplitude of modulating signal, the noise will get increased.